The next constructions we'll look at are built off of the ideas of parallel, intersecting, and transversal lines, where the easiest thing to do with this type of problem is just take an example, a diagram, and build our definitions off of that. So let's say we've got something like this here, where the two lines on the top and bottom are what we would call our parallel lines. Those are lines that, if you want to think about them in terms of slope, they have the same slope, but they're not equal. So one kind of goes one way, the other's below it. They never touch. They just keep going and going and going forever and ever across from each other in some sense. And then between them, connecting them in a way, going across, is what's called our transversal. It's a line that intersects two parallel lines. And this construction of those three lines leads to a bunch of really important relationships with angles that give us a whole bunch of measures, just like what we saw with the vertical angles in the previous example. So here we're just going to run through a bunch of these definitions. So first, we have what are called alternate interior angles. So these are ones that don't have a common vertex on alternate sides of the transversal. They're kind of funky looking. You can think of them as 3 and 6 on the diagram, or 4 and 5. But the nice thing here is, based on the construction, based on the fact that they're kind of supplements for the same thing, they have the same measure. Then we have alternate exterior angles. So those are angles like 1 and 6, where again, for that same sort of relationship between things like exterior angles and supplements, those will also be equal. And then finally, we have the corresponding angles, of which you're going to see a whole lot of them in that diagram. Those, again, for the same type of logic, are also always going to be equal. That's a lot of potential things we can do here with those angles. So the best thing to do to practice with this, to get a sense of what is going on here with all of those options, is to look at an example. Where what we're going to do is look at the diagram that's given and try and make some identifications, pick all of our pieces up. So we've got our mess of transversal and parallel up there, and what we want to do is pull out all the pieces of it. Identify all of those angles. And the fun thing here is we actually can do this in a whole bunch of ways, depending on how we want to approach it. Well, the only thing we're given here is the measure of angle 8. Okay? So let's think about how we can get all the way back to the start, going from 8 in reverse. We have that the measure of angle 8 is equal to 35 degrees. Well, let's look at that, look at what's near it, think about how we get to 7, and see that 7 and 8 are supplementary angles. So 35 would also, 35 would not be the measure of angle 7, but this would tell us that the measure of angle 7 would be equal to 180 minus 35, or 145 degrees. And then from there, we could see that 7 and 6 are, what would the word for that be? Exterior angles. They're the ones that are opposites in there. Let me make sure I have that name just right. I believe I do. Anyway, we have those two angles, which tells us that the measure of angle 6 is also 145 degrees. I'll be extra clear about writing that name down. And then we'll jump over to angle 5, where 5 and 8 are corresponding angles, using that previous idea from that table that we looked at before. So, since 5 and 8 are corresponding angles, the measure of angle 5 is going to be the same as 8, it will be 35 degrees. Then we're going to try and find angle 4. Well, we've got supplements again. So the measure of angle 4 is going to be another 145. And look, for 3, we can do the same thing that we did going from 6 to 7. That will end up being the same as 4. Then 2, again, is going to be a supplement of 3, or alternatively, it is the opposite, that's the way I want, the opposite angle of 5. But in either case, we get 35 degrees, and finally we're left with angle 1, which, yet again, would be corresponding angle to 2. So we have another 35 degrees. And that's just one way you could go about this problem, because we have so many different relationships that we can call upon, so many different ways that we can connect pairs of angles here. There are a great deal of ways we could approach this that would bring us all of these answers, but that's just one way you could do it.